40-pound box pulled across the floor as shown. 22 pounds required to start the box moving. Determine coefficient of static friction. Free body diagram required. Wow, we've looked at lots of these. So obviously we're dealing with a friction problem here. Also the angled force and the weight of the box. Probably the key thing to see here, 22 pounds required to start. Alright, so that's saying this angled force needs to be 22 pounds to overcome static friction. So this is our impending motion case. Okay, so we know that at a pending motion, it's required to start. That's what tells us that. And only at a pending motion, the force of friction is equal to mu sub s times the normal force. So that's a key point to get right here. Let's go ahead and draw a free body diagram. 22 pounds, angle of 25 degrees. Okay, we're going to have weight of 40 pounds. We're going to have a normal force. Don't make a mistake of saying that a normal force is equal to the weight. This angled force is going to make that not true. And friction. Standard coordinate system. Okay, let's look at the y direction first. We know a lot about that. We're going to break, as we've done almost all these problems, break this into two components, an x and a y component right here. Okay, so that y component is going to be 22 pounds times the sine of 25. And that's going upward, so it's positive. We have a minus 40 pounds going down, and we have n going up, and no acceleration. Okay, we're at impending motion. So we can solve this for n. Let's see, looks like it's going to be 40 minus 22 sine 25, 30.7. So again, n is not the weight. It's less than the weight because of this vertical component of the pulling force. Okay, let's see what we have in x now. Well, we have 22 pounds cosine 25, and that's going to be in the positive x, and we're going to have the force of friction in the negative x direction. That's going to be equal to 0. Okay, I know from right here, impending motion, an equation for force of friction, and that's going to let me calculate the static coefficient of friction. Alright, so let's rewrite this. We'll have mu sub s times n, moving that over to the other side, is equal to 22 cosine 25. So mu sub s equals 22 over 30.7 cosine 25. Putting off all my calculator to the end here. I believe that's correct. Let's punch it out. Let's see, so I have 22 divided by my previous answer times cosine 25. 0.6494. 649. Alright, that wasn't too bad. 0.649. Coefficient of static friction and kinetic friction are both unitless. These were both pounds over pounds. Of course, cosine of 25 is a unitless number as well.